Let me wait to see if it's streaming. So I'm listening to Andrew Huberman's podcast while I drive. And as I was driving today, I listened to one of his podcasts. He talks about that a good time seems to be an optimal time for concentration is 90 minutes. So I'm thinking about doing 90-minute sessions every time I do these streams, like put a 90-minute timer and then stop, like Pomodoro style. I remember I tried to do another way, which is to go until I feel like I'm tired and then take a break. But I think with this way, I end up not taking breaks because I just wanna keep going. So putting the timer is probably better. But yeah, today I'm gonna spend only 90 minutes because of that and because I have to do other stuff off stream. And but the next times, probably tomorrow or the day after tomorrow, I'm gonna when I stream for longer hours, I'm gonna try to do that. I'm gonna try to break it down in 90 minutes periods and then give 20 minutes of meditation or something like that. I still because one of the issues is that if you stop streaming, then it's harder to go back because I don't know why. Probably because I start doing other stuff off stream, and then it's kind of like a momentum type of thing. But then if you meditate, it feels like uh, it's weird because you're streaming, and then it feels like you're supposed to should be doing something. So I'll have to figure out what is a good balance, whether or not I should take the 20 minutes break of meditation or just stop streaming and then come back again. I think also the thing that makes it harder is because I have to find titles to put because each stream has to have a different title, so I'm able to differentiate the videos later. So that's kind of an annoying thing that for stopping and continuing the stream all the time in the same day. But yeah, so today I'm gonna study the Spark thing here. I was gonna help use GPT to help me structure the loops videos, but then I remember that I saved the code for the last time that I did that for the loops. And I think that's all I need for that video. I think the only thing, the last video I did, which is for if-else statements, I showed the code side by side and then I highlighted. And this is the thing that I'm debating now because the last video I almost couldn't highlight the videos because it takes, I didn't know this, but it takes a lot of the GPU in order to be able to do that. And my GPU is not very good. So when you highlight multiple things, you have to put a bunch of stuff in the Fusion page on DaVinci Resolve. And I almost, it kept crashing the DaVinci Resolve. I had to re-edit everything after I had done the video because it crashed. Then I couldn't access the edits that I made and I had to redo everything again. So that's one concern that I have. But if it ends up working out, I think I'm gonna, what I did in the previous video was highlight everything in red that is fundamental to the structure. So for example, in this case would be for, in, and these dots here. And then highlighting green, everything that changes depending on the application. So, and then probably to explain for loops as well, I'm gonna use some arrows, try to draw some arrows, and maybe if it isn't too hard or if I'm able to do it with the GPU that I have using DaVinci Resolve, what I wanted to do is like a simulation of, yeah, but I'm probably not gonna do that just because it's really hard and I might not be able to do it. But what I have in my mind, the idea I have in my mind, is to do the animation showing the one going here. So first showing this taking the place of the numbers, and then replacing the elements with one, or doing an animation that the one goes to here and then the two. So that is very visual and makes it easier for people to understand what's going on. Because I remember when I was starting to code, I had problem understanding the map, so array.map, because I couldn't understand in my mind based on the way that people explained that this symbol here was gonna be each element of the array. That was the hardest part for me to understand this, because everything else felt really easy, but then because I couldn't, it wasn't explained really well how this connection is made here, because I didn't know like if I could put anything here, like what exactly do I have to put E? What exactly is this? And I think making it easier to people for people to visualize this symbol taking place and talking about that and showing them that this becomes each thing, I think it's gonna make it easier for people to understand. But yeah, this is not related to what I'm gonna do today. And this is the outline that I have for the next videos. But it shouldn't be that hard to make that video. So what I'm gonna do today is go over all these topics here of Spark. And if I have time, then Redis as well. And I'm just gonna put this on ChatGPT and see what comes up with. And hopefully ChatGPT is not gonna be too expensive once they. My concern is if they make it based on how many commands you give instead of a monthly payment or something like that. Because if they do it like that, then it becomes arbitrary. It's harder for you to predict how much you're gonna spend a month, and then it becomes difficult to access whether or not I'm gonna be able to pay it for to use. But I definitely think it's valuable. I made some questions off streaming and I can think about a lot of different applications to use ChatGPT that is gonna help me a lot with a bunch of different stuff. Yeah, so I'm not sure if this is. It seems that it is all the response, but it's probably not a good one. Okay, so it does explain each one. If it didn't, I would just type continue to see if it says anything else. I'm gonna put a bunch of this. I'm gonna do just like I did last time, where I put a bunch of this and then I just use the text-to-speech to read the stuff. Because otherwise I get too tired reading. I think this one it didn't finish because of the bullet points here, but maybe it did. Okay, so it did. So this question, I probably wrote down the options and it was asking which one of the options is true. So I don't think it's very useful to put the whole input there. So I'm gonna see, can you give me an in-depth explanation of how Spark SQL works? I think that's a better way to do it. In these kinds of questions, I've been seeing that it works really well, especially when you ask a broad question first, and then it gives you, because then it remembers the context of the question for the next question. So first you give a broad question where it talks about the overall general thing, and then you ask for it to show you some code or example related to the previous question, and then it goes more in detail in that. But a lot of the times it's hard to know. I think this one doesn't have anything more. A lot of the times it's hard to know which questions to ask so that you get the best answers. I'm not sure about this one, so I'm just gonna copy this one. I didn't make that good of notes because when you're doing the test, there's a time, obviously, because otherwise you could just spend forever on Google searching for the answers. So I wanted to write information about all the questions, so I had to just write down really fast. And some of these ended up not being really good explanations, or I couldn't capture what it was trying to test, the fundamental thing. And a lot of these questions I also think don't make sense. And the same thing with the educational system is we haven't been able to figure out a more efficient way to test for this kind of stuff, even the hiring process. So most of the hiring process and the school system is really dumb because of that. They ask a bunch of questions that are useless. But it's not their fault, it's just hard problem to solve. I think I'm just gonna copy this one. Hopefully it says something useful. Just waiting a little bit so that I'm still not sure whether or not it gives me the maximum or too many requests based on the number of requests for each thread or because of the speed that I'm queuing the thing. But I'm waiting a little bit just in case that it is the speed so I can ask more questions by thread. One thing that I wonder is if they're gonna do a feature that allows the thing to translate itself to other languages. I think that would be really interesting. But I imagine maybe maybe it is possible because I don't know what kind of data it was trained on exactly. But yeah, if it was trained on stuff that is only in English, then obviously it would be impossible to translate. Maybe actually maybe not because maybe you can do another model that just translates between languages. You train a model to. Yeah, I wonder why they haven't done that yet. Actually, now that I think about it. Yeah, it actually seems maybe they have, probably. The Google Translator is that, probably. But why not connect that with ChatGPT? Because translating through between two different languages seems like a much easier problem than creating something like ChatGPT, because you know all the possible syntax for both languages. So it seems like maybe it doesn't even require machine learning to be able to do that. It's like creating a compiler. It's pretty much the same thing. So I think I'm gonna count, and if it's over half, I'm gonna start the text to speech. One, two, three, four. Yeah, this one is 10. One, two, three, 6, 7, 8, 9, 10, 11. Okay, I think, yeah, maybe I'll wait over half. So maybe this and another one. But actually, I think one more, and then I'll start the text to speech and then reset the thread after that.
Spark SQL code is processed by executive nodes. Spark SQL code is processed by executive nodes. The driver node is responsible for orchestrating the execution of the Spark SQL code by dividing the code into tests and distributing them to the executor nodes for processing. The cluster manager is responsible for managing the resources of the cluster, such as scheduling the executor nodes and allocating required resources for each job. RDD, Resilient Distributed Data Set, is the lowest level and most immutable data abstraction in Spark. It represents a distributed collection of objects. Spark SQL code is processed by executor nodes. The driver node is responsible for orchestrating the execution of the Spark SQL code.
The driver node is responsible for orchestrating
the execution of the Spark SQL code by dividing the code into tasks and distributing them to the executor nodes for processing. The cluster manager is responsible for managing the resources of the cluster, such as scheduling the executor nodes and allocating the required resources for each job. RDD, Resilient Distributed Data Set, is the lowest level and most immutable data abstraction in Spark. It represents a distributed RDD, Resilient Distributed Data Set, is the lowest level and most immutable data abstraction in Spark. It represents a distributed collection of objects that can be processed in parallel. Roads are fault-tolerant and can be used to perform a wide range of data operations. Data frames are built on top of roads and provide a more structured and tabular data representation. They allow for a higher level of abstraction and provide APIs that are more intuitive and easier to use than roads. Data frames also have a schema that defines the data types of each column, which enables Spark to optimize the execution of queries. Datasets are a type of data frame that provide the ability to work with strongly typed data. This means that the data in a dataset is already mapped to a specific type, such as a case class in the Scala programming language. This makes it easier to work with the data and reduces the chances of errors due to incorrect data types. Like data frames, datasets also provide a higher level of abstraction and a more intuitive API than roads. Is there anything else?
Okay, so that's pretty intuitive. So the RDD is like a lower level language, and then on top of that, so it's like RDD is assembly, and then data frames is C++, or RDD is C, data frames is C++, and datasets is Python or JavaScript. And it's just a hierarchy of abstractions to manipulate data. And what changes between them is the APIs, and the higher you go, the easier it is to write, but then probably the slowest it is, I imagine.
Is there anything else you would like to know about Apache Spark or its data abstractions? I would be happy to provide additional information if you have any specific questions. Sure, I'd be happy to provide an in-depth explanation of how Spark SQL works. Spark SQL is a module in Apache Spark that enables efficient processing of structured and semi-structured data. It provides a programming abstraction called data frames and a SQL query engine that allows users to perform powerful data manipulations and analysis on large datasets. Spark SQL uses a technique called schema on read, which means that it does not require users to define the schema of the data up front. Instead, it infers the schema of the data when it is read from a source, such as a file. This makes it possible to work with unstructured or semi-structured data, such as JSON or CSV files, without having to pre-process the data to define a fixed schema. When a Spark SQL query is executed, the driver node parses the SQL query and converts it into a logical plan that is composed of a series of transformations on the input data. These transformations are then executed by the executor nodes in parallel, with each node operating on a partition of the input data. The results from each executor node are then sent back to the driver node and combined to produce the final result of the query. Spark SQL also includes a highly optimized query engine that uses techniques such as columnar storage, code generation, and query optimization to execute queries as efficiently as possible. This allows Spark SQL to process large amounts of data quickly and efficiently, making it a powerful tool for data analysis and machine learning. Overall, Spark SQL provides a convenient and efficient way to process structured and semi-structured data in Apache Spark. It allows users to express their data processing requirements using a familiar SQL-based syntax and offers powerful features for data manipulation and analysis. In Apache Spark, the result of a Spark SQL query is typically returned to the driver node as a data frame or dataset. However, there are some situations where the result may not be returned to the driver, such as when using certain actions on an RDD. For example, the collect, top, count by value, and for each actions all operate on an RDD and return the result directly to the executor nodes instead of the driver. The collect action is used to return all the elements of an RDD to the driver as an array. This is useful for testing and debugging, but it can be inefficient for large roads because the entire dataset needs to be transferred from the executor nodes to the driver node. The top action is used to return the top n elements of an RDD, where n is specified by the user. This is similar to the collect action, but it only returns a subset of the RDD instead of the entire dataset. The count by value action is used to count the number of times each unique value appears in an RDD. This action returns a map of each unique value to its count, with the results being returned directly to the executor nodes. The for each action is used to apply a function to each element of an RDD. This action does not return a result, but it can be used to perform some computation on each element of the RDD, such as writing the elements to a file or sending them to a remote service. In general, actions that operate on an RDD and return the result directly to the executor nodes can be more efficient than those that return the result to the driver. But they can also be less flexible and require more careful consideration when designing a Spark SQL query. Stateless transformation, data from previous batches and computes the result of the current batch, windowed operations, and update state by key, are two types of stateless transformation. Processing of each path has no dependency on the data on previous batches. In Apache Spark, a stateless transformation is a type of transformation that does not depend on the data from previous batches when computing the result of the current batch. This means that the processing of each batch is independent and has no dependency on the data of previous batches. Examples of stateless transformations include map, filter, and group by. Stateless transformations are useful because they can be easily parallelized and distributed across the executor nodes in a cluster. This allows Spark to process large amounts of data quickly and efficiently, with each executor node operating on a different part of the input dataset. Windowed operations and the update state by key operation are two types of stateless transformations that are commonly used in Apache Spark. Windowed operations allow users to apply transformations to a sliding window of data, such as the last 10 minutes of data or the last 100 records. This can be useful for performing real-time analysis on streaming data. The update state by key operation is a specialized stateless transformation that is used to update the state of an RDD based on the values of each key. This operation is commonly used in stateful stream processing, where the state of the data is maintained across multiple batches of data. In summary, stateless transformations are an important concept in Apache Spark, as they allow for efficient and parallelizable data processing. Windowed operations and the update state by key operation are examples of stateless transformations that can be useful for specific data processing tasks. Action of RDD, ways to send result from executors to driver, takes RDD as input and produces one or more RDD as output, creates one or many new roads. An action is a type of operation in Apache Spark that returns a result to the driver node. Actions take an RDD as input and produce one or more roads as output. Unlike transformations, which are lazy and do not compute a result until an action is called, actions are eager and trigger the execution of a Spark SQL query. There are several ways to send the result of an action from the executor nodes to the driver node in Apache Spark. One common way is to use the collect action, which returns the entire RDD to the driver as an array. This can be useful for testing and debugging, but it can be inefficient for large roads because the entire dataset needs to be transferred from the executor nodes to the driver node. Another way to send the result of an action to the driver is to use the take action, which returns a fixed number of elements from the RDD. This can be more efficient than collect, because it only transfers a subset of the data to the driver, but it also has limitations because it only returns a fixed number of elements. Another option is to use the save action, which writes the RDD to a persistent storage system, such as HDFS or S3. This allows the result of the action to be accessed later, even after the Spark SQL query has completed. In general, actions are a key concept in Apache Spark, as they allow users to trigger the execution of a Spark SQL query and obtain the result of the computation. There are several ways to send the result of an action from the executor nodes to the driver node, depending on the specific needs and requirements of the query. When a Spark SQL query is executed, it goes through several phases of execution, including analysis, logical optimization, physical planning, and execution. The first phase is analysis, where the driver node parses the SQL query and verifies that it is syntactically correct. This includes checking the syntax of the query, resolving the names of any tables or columns referenced in the query, and verifying that the data types of the columns are compatible with the operations being performed. The next phase is logical optimization, where the driver node optimizes the logical plan generated in the analysis phase. This includes applying any transformations or optimizations that can be performed on the logical plan, such as pushdown filters, column pruning, and predicate pushdown. These transformations can help to improve the performance of the query by reducing the amount of data that needs to be processed. The physical planning phase is where the driver node generates the physical execution plan for the query. This involves mapping the logical plan to the underlying execution engine, such as the Spark Core engine or the Spark SQL engine, and generating the code that will be used to execute the query. This phase also includes any additional optimizations that can be performed at the physical level, such as code generation and pipelining. Finally, the execution phase is where the query is actually executed by the executor nodes. This involves dividing the query into tasks and distributing them to the executor nodes for processing, with each node operating on a partition of the input data. The results from each executor node are then sent back to the driver node and combined to produce the final result of the query. Overall, the execution of a Spark SQL query goes through several phases, each of which plays a critical role in the performance and efficiency of the query. By understanding these phases, users can better design and optimize their queries to achieve the desired performance and scalability. Feature of Spark Engine: scheduling, distributing data across a cluster, monitoring data across a cluster. There are several key features of the Apache Spark Engine that enable it to efficiently process large amounts of data. These include scheduling, distributed data storage and processing, and monitoring and fault tolerance. One of the key features of the Spark Engine is its ability to schedule and distribute the execution of tasks across a cluster of compute resources. The driver node is responsible for dividing the workload into tasks and scheduling them on the executor nodes. This allows Spark to parallelize the execution of a query and
Let me go back on this one. And let me spend some time. So the driver node divides the workload and scheduling them on executor nodes. Okay.
The driver node is responsible for dividing the workload into tasks and scheduling them on the executor nodes. This allows Spark to parallelize the execution of a query and distribute the workload across the available resources, which can improve the performance and scalability of the query. Another important feature of the Spark engine is its ability to distribute data across a cluster. This is achieved through the use of resilient distributed datasets, RODs, which are the fundamental data abstraction in Spark. RODs are distributed across the executor nodes and can be processed in parallel, which allows Spark to efficiently process large datasets that are too big to fit on a single machine. In addition to scheduling and data distribution, the Spark engine also includes features for monitoring and fault tolerance. The driver node is responsible for monitoring the execution of tasks on the executor nodes and providing feedback to the user about the progress of the query. The Spark engine also includes mechanisms for fault tolerance, such as the ability to automatically recover from failed tasks and lost data. Overall, the features of the Spark engine make it a powerful tool for distributed data processing and analysis. Its ability to schedule, distribute, and monitor the execution of tasks across a cluster allows it to efficiently and reliably process large amounts of data. Uses of Apache Spark SQL: it executes SQL queries, read data from existing Hive by installation using Spark SQL. When run SQL within another programming language, we will get the result as dataset or data frame. Apache Spark SQL is a module in Apache Spark that enables efficient processing of structured and semi-structured data. There are several uses for Spark SQL, including the following. Executing SQL queries. One of the primary uses of Spark SQL is to execute SQL queries. This allows users to express their data processing requirements using a familiar SQL-based syntax, which can be more intuitive and easier to use than the Spark Core API. Reading data from existing Hive installations. Spark SQL can be used to read data from an existing Hive installation using the Spark SQL command. This allows users to leverage their existing Hive data and metadata, such as table definitions and partitioning schemes, in their Spark SQL queries. Providing a SQL interface to other programming languages. Spark SQL can be used as a SQL interface for other programming languages, such as Python and Scala. When running SQL within another programming language, the result of the query is returned as a dataset or data frame, which can be easily manipulated and processed using the APIs provided by the programming language. Overall, Apache Spark SQL provides a convenient and powerful way to process structured and semi-structured data in Apache Spark. Its ability to execute SQL queries, read data from existing Hive installations, and provide a SQL interface to other programming languages makes it a valuable tool for data analysis and machine learning. Apache Spark supports a wide range of data processing and analysis capabilities, including batch processing, stream processing, and graph processing. Batch processing is a common data processing pattern where a large dataset is processed in fixed-sized chunks, or batches. In Spark, batch processing is supported through the use of RODs, resilient distributed datasets, which are distributed collections of data that can be processed in parallel. Batch processing allows Spark to efficiently process large amounts of data and perform complex data transformations and analysis. Stream processing is a data processing pattern where data is processed as it arrives in real time, typically in the form of a continuous stream of records. In Spark, stream processing is supported through the use of the Spark Streaming API, which allows users to process streams of data and perform real-time analysis on the data as it arrives. This can be useful for applications such as real-time analytics, fraud detection, and event processing. Graph processing is a data processing pattern where data is represented and processed in the form of a graph, with nodes representing entities and edges representing relationships between the entities. In Spark, graph processing is supported through the use of the GraphX API, which allows users to perform complex graph algorithms and analysis on large-scale graphs. This can be useful for applications such as social network analysis, recommendation engines, and fraud detection. Overall, Apache Spark supports a wide range of data processing capabilities, including batch processing, stream processing, and graph processing. These capabilities make Spark a versatile and powerful tool for data analysis and machine learning. Fault tolerance in RDD can be achieved by immutable nature of RDD, DAG, directed acyclic graph, lazy evaluation. Fault tolerance in Apache Spark is the ability of the system to continue operating and providing correct results in the presence of failures. Fault tolerance in RODs, resilient distributed datasets, the fundamental data abstraction in Spark, can be achieved through a combination of the following factors. Immutable nature of RODs. RODs are immutable, which means that once they are created, they cannot be modified. This makes it easy to recover from failures because the state of an RDD can always be reconstructed from its lineage, which is a sequence of transformations that were applied to create the RDD. DAG, directed acyclic graph, of transformations. RODs are created through a series of transformations, which are represented as a DAG, directed acyclic graph. This means that the dependencies between different RODs.
If I'm not mistaken, this is also used in zero-knowledge proofs, where you have a graph, you have the information encoded in a directed acyclic graph that makes the proof of the thing based on the operators and the variables.
This means that the dependencies between different RODs can be easily tracked and used to recover from failures. For example, if an RDD is lost, it can be reconstructed by reapplying the transformations in its lineage to the input data. Lazy evaluation. In Spark, transformations on RODs are lazily evaluated, which means that they are not executed.
That's actually, now that I think about it, a good question to ask as well. Maybe after I'm done with the Spark thing, I'm gonna ask this because it just popped up in my mind, but ask it to explain zero-knowledge proofs should be really interesting.
Lazy evaluation. In Spark, transformations on RODs are lazily evaluated, which means that they are not executed until an action is called. This allows Spark to delay the execution of a query until all of the transformations have been defined, which makes it possible to optimize the query and recover from failures. Overall, fault tolerance in RODs is achieved through a combination of the immutable nature of RODs, the DAG of transformations, and lazy evaluation. These factors enable Spark to recover from failures and continue providing correct results. RODs, resilient distributed datasets, are the fundamental data abstraction in Apache Spark and are often used for simple grouping and aggregation operations. However, RODs can be slow for these types of operations because they require the data to be processed in a distributed manner, which can be inefficient for small datasets. To address this issue, Spark provides two higher-level data abstractions, data frames and datasets. These data abstractions are built on top of RODs and provide a more structured and intuitive API for working with data. They also include features such as a schema that defines the data types of each column, which enables Spark to optimize the execution of queries. As a result, data frames and datasets can be more efficient than roads for simple grouping and aggregation operations, especially for smaller datasets. They provide a higher level of abstraction and a more intuitive API, which can make it easier and more efficient to perform these types of operations. In summary, roads can be slow for simple grouping and aggregation operations because they require the data to be processed in a distributed manner. Data frames and datasets provide a more efficient and intuitive alternative for these operations, especially for small datasets. Free research preview, ChatGPT is optimized for dialogue.
Yeah, so basically RDDs are used to decentralize the data into multiple different computers using clusters. And the other ones are more efficient for smaller data because you don't need to go through these steps that are required for the data to go through in order to be able to decentralize it into multiple computers. I think I understand it far better now. I think I'm gonna read this one out loud and then I'll reset the thread and get the rest of them. Yeah, I think there's gonna be plenty of time after that, but maybe not actually, because this took 20 minutes, I think. But there's probably gonna be some time after I finish with this document to ask about zero knowledge proofs and then go to the Redis one. Also debating whether or not should make another. I should probably make another folder inside of this one. I wish there was a way to change the color of this document to mark the ones that I have gone through already, but I don't think that is. I think only bash scripting I've done all the way. Here. The read operation of an RDD is typically a coarse-grained operation. This means that the entire input data set's read and partition it into smaller chunks or partitions that can be processed in parallel by the executor nodes. Coarse-grained operations are efficient for distributed data processing because they allow Spark to parallelize the execution of a query and distribute the workload across the available resources. However, they can also be less flexible than fine-grained operations because the entire input dataset needs to be read and partitioned before the query can be executed. Fine-grained operations, on the other hand, operate on individual elements of an RDD and can be more flexible than coarse-grained operations. For example, map transformation is a fine-grained operation because it applies a function to each element of an RDD and returns a new RDD. Fine-grained operations can be useful for performing complex transformations on an RDD, but they can also be less efficient than coarse-grained operations because they require more computation and communication between the executor nodes. In summary, the read operation of an RDD is typically a coarse-grained operation, which allows Spark to efficiently distribute the workload across the available resources, fine-grained operations. Oh, maybe it isn't finished. Celery is a powerful and popular tool, open sourced. Through the data processing platform, it provides a rich. Yeah, I think I lost the output here because I made this typo, or maybe. Okay. Fine-grained operations are also available in Apache Spark and can be useful for performing complex transformations on an RDD. However, they can be less efficient than coarse-grained operations because they require more computation and communication between the executor nodes. Overall, the choice between fine-grained and coarse-grained operations depends on the specific requirements and needs of the query. Maybe the response for this one is not gonna be very good, but I don't think I'm gonna change it.
The read operation of RDD is typically coarse-grained. This means that the operation is applied.
This means that the operation is applied to the entire RDD as a whole, rather than being applied to individual elements within the RDD. Coarse-grained operations are typically more efficient because they allow for more parallelism and can take advantage of distributed computing systems like Apache Spark. However, it's worth noting that the granularity of an roads read operation can vary depending on how the RDD is created and used. Shortcoming of MapReduce can be overcome by Spark RDD of lazy evaluation, DAG, in-memory processing. One of the shortcomings of MapReduce is that it is not very efficient for iterative or interactive algorithms, because it requires data to be read from and written to disk between each iteration. This can be overcome by using Spark roads, which support in-memory processing. This means that data can be cached in memory and accessed much more quickly than if it had to be read from disk. In addition, Spark roads support lazy evaluation, which allows computations to be delayed until the results are actually needed. This can further improve the performance of iterative algorithms by avoiding unnecessary calculations. Finally, Spark roads use a directed acyclic graph, DAG, to represent the data flow in a computation, which can help optimize the execution of operations and improve performance. Spark Shell helps Spark apps to easily run on command line of system, runs and tests apps code interactively. It allows reading from many types of data sources. Yes, that's correct. The Spark Shell is a command line interface that allows users to interactively run and test Spark applications. It is a useful tool for quickly trying out code and experimenting with different algorithms. The Spark Shell also makes it easy to read data from a wide variety of sources, including files, databases, and other storage systems. In addition, the Spark Shell allows users to connect to a Spark cluster and run their applications in a distributed environment, which can improve performance and scalability. Rules in Catalyst Optimizer can manipulate tree using rules, can define rules as a function from one tree to another tree. Using rule we get the pattern that matches each pattern to a result. Yes, that's correct. The Catalyst Optimizer in Apache Spark uses a set of rules to manipulate the abstract syntax tree, AST, of a Spark SQL query and generate an optimized logical plan. These rules are defined as functions that take a tree as input and return a transformed tree as output. The optimizer uses these rules to reorder and combine operations in the query, which can improve the performance and efficiency of the execution. The primary machine learning API in Apache Spark is the DataFrame and DataSet APIs. These APIs provide a high-level, declarative interface for specifying machine learning algorithms and pipelines, and they are designed to be familiar and easy to use for users with a background in SQL or Pandas. The DataFrame and DataSet APIs also offer a number of advantages over the older RDD API, including automatic optimization and increased performance, support for a wider range of data types, and a more concise and expressive syntax. In general, the DataFrame and DataSet APIs should be the first choice for most machine learning tasks in Spark. Logical plan in Spark SQL optimization, constant folding, abstract syntax tree, projection pruning, predicate pushdown. The logical plan in Spark SQL optimization is a representation of the transformations and operations that will be applied to the input data to produce the desired query results. This plan is generated by the optimizer and it serves as a blueprint for the physical execution of the query. The optimizer applies a number of optimization techniques to the logical plan, such as constant folding, projection pruning, and predicate pushdown, in order to generate an optimized plan that will execute efficiently. The logical plan is typically represented as an abstract syntax tree, AST, which is a tree-like structure that represents the hierarchical relationship between the different operations in the query. Yes, that's correct. Apache Spark Core is the kernel of the Spark platform, and it is responsible for providing the basic functionalities that are used by all of the other components of Spark. It includes the distributed execution engine, the in-memory data storage and computation capabilities, and the APIs for programming Spark applications. Spark Core enables users to run SQL or HQL queries on top of Spark, and it supports a wide range of data sources and formats. Additionally, Spark Core is designed to be highly scalable, allowing users to easily run their applications on large clusters of machines. Machine learning library which delivers efficiencies, it improves the performance of iterative algorithm drastically. One machine learning library that can improve the performance of iterative algorithms is Apache Spark mlib. This library is specifically designed for scalable machine learning, and it provides a wide range of algorithms and tools for working with large datasets. mlib includes efficient implementations of common machine learning algorithms, such as linear regression, decision trees, and clustering, that are optimized for distributed computing environments like Spark. Additionally, mlib includes tools for feature extraction, transformation, and selection, which can help improve the performance of iterative algorithms by reducing the dimensionality of the data and making it more amenable to efficient processing. Overall, mlib can help deliver significant efficiencies in the development and deployment of machine learning applications. One module in Apache Spark for structured data processing is Spark SQL. Spark SQL is a module for working with structured and semi-structured data, such as tables in relational databases, JSON documents, and CSV files. It provides a SQL-like interface for querying and manipulating data, and it integrates with the rest of the Spark ecosystem to support distributed and scalable data processing. Spark SQL includes a number of features that make it well suited for structured data processing, such as support for a wide range of data sources, a built-in optimization engine, and the ability to combine SQL queries with other types of operations. Free research preview, ChatGPT is optimized for dialogue.
Yeah, nice. I think just gonna do this directly because I can search for the zero knowledge stuff later. Just wanna get through this stuff first. Yeah, maybe if I should finish this one fast, then I search for the zero knowledge stuff. These here were the options, I think. So I think it makes sense to put that there. Nice. Looks like the food is gonna be here soon as well. So I might have to stop earlier than 90 minutes. Hopefully I can go through all of this stuff while I was still free. I think it's unlikely because it's too many things here. But given how fast I was able to go through these ones, maybe it is possible. If it takes me 1.5 hours to go through each one, maybe, yeah, it's still a shit ton of time. But I suspect some of them are gonna have less information, so it's probably faster. Maybe I should try to go as fast as possible with this queries here, and then just see when it stops because of too many requests, and then try to reset the thread because that way I don't need to wait too much. Just have to wait for it to compute the answer. But I don't wanna put too many requests on their server as well, because I know there's a lot of other people using this. So Quite crazy to think about how this is actually working on the language model. Like how the fuck is it possible that gets just a little input and then is able to put all of this stuff together? It's really crazy to think about. Just using weights and biases is kind of insane.
Sure. Redis is an in-memory data structure store, often used as a database cache.
Redis is an in-memory data structure store, often used as a database, cache, or message broker. It supports a variety of data structures, including strings, hashes, lists, sets, and more. In Redis, a transaction is a sequence of commands that are executed as a single unit, either being executed all at once, or not at all. This is useful for ensuring the atomicity of operations, where either all of the operations in the transaction are executed, or none of them are. To start a transaction in Redis, you can use the multi command. This tells Redis that the following commands should be executed as a transaction. For example, multi set key 1 value 1 set key 2 value 2 exec. In this example, the multi command is used to start a transaction, and the set commands are used to set the values of key 1 and key 2 in Redis. Finally, the exec command is used to execute the transaction. If the transaction is successful, all of the set commands will be executed and the values of key 1 and key 2 will be set. If you want to cancel a transaction before it has been executed, you can use the discard command. This will discard any pending commands in the current transaction, and return Redis to its normal state. Multi set key 1 value 1 set key 2 value
Let me
2
go
discard.
back.
To start a transaction in Redis, you can use the multi command. This tells Redis that the following commands should be executed as a transaction. For example, multi set key 1 value 1 set key 2 value 2 exec. In this example, the multi command is used to start a transaction, and the set commands are used to set the values of key 1 and key 2 in Redis. Finally, the exec command is used to execute the transaction. If the transaction is successful, all of the set commands will be executed and the values of key 1 and key 2 will be set. If you want to cancel a transaction before it has been executed, you can use the discard command. This will discard any pending commands in the current transaction, and return Redis to its normal state. Multi set key 1 value 1 set key 2 value 2 discard. In this example, the discard command is used to cancel the transaction before it is executed. This means that the values of key 1 and key 2 will not be set. Finally, the watch command can
be used to monitor one or more keys in Redis. If any of the watched keys are modified before the transaction is executed, the transaction will be automatically cancelled. This can be useful for implementing optimistic locking, where a transaction is only executed if the data it is modifying has not been changed since it was read. Watch key 1 multi set key 1 value 1 exec. In this example, the watch command is used to watch the key 1 key. If the value of key 1 is modified before the exec command is called, the transaction will be cancelled and the set command will not be executed. I hope this helps. Let me know if you have any other questions about Redis. Yes, Redis supports high availability, through the use of Redis Sentinel and Redis Cluster. Redis Sentinel is a distributed system that provides high availability for Redis. It does this by automatically detecting when a Redis server has failed, and then promoting one of the slave servers to be the new master. This allows Redis to continue operating even if the master server fails, with minimal downtime. Redis cluster is a distributed system that allows you to shard your data across multiple Redis nodes. This allows you to horizontally scale your Redis deployment, and provides automatic data partitioning and rebalancing, which can improve performance and availability. Together, Sentinel and Cluster can be used to provide high availability and scalability for Redis. Sentinel can monitor the health of the Redis servers and automatically promote new masters, while Cluster can shard your data across multiple nodes, providing both high availability and performance. In Redis, the publish/subscribe, pub/sub, pattern is a messaging pattern where clients can subscribe to channels and receive messages that are published to those channels. This allows clients to receive real-time updates from Redis, making it a useful tool for building real-time applications. To use the pub/sub pattern in Redis, clients first need to subscribe to one or more channels. This is done using the subscribe command. For example, to subscribe to the news channel, a client would run the following command: subscribe news. Once a client has subscribed to a channel, it will receive all messages that are published to that channel. To publish a message to a channel, you can use the publish command. For example, to publish a message to the news channel, you could run the following command: publish news hello, world. In this example, the publish command is used to publish the message hello, world, to the news channel. Any clients that are subscribed to the news channel will receive this message, and can then act on it in some way, for example, by updating their user interface to display the new message. The pub/sub pattern in Redis is useful for building real-time applications, such as chat rooms, live updates, and more. It allows clients to receive real-time updates from Redis, without the need to constantly poll the server for new data. This can improve the performance and scalability of your application. Fragmentation ratio not reliable when you had memory usage that at peak is much larger than the currently used memory. You are correct that the fragmentation ratio is not a reliable measure of memory usage in Redis if the peak memory usage is much larger than the current usage. This is because the fragmentation ratio is calculated by dividing the amount of memory that is used for storing data by the total amount of memory allocated to Redis. If the peak memory usage is much larger than the current usage, then the total amount of memory allocated to Redis will be much larger than the amount of memory actually being used for storing data. In this case, the fragmentation ratio will be relatively low, even if the memory usage is inefficient. For example, let's say that Redis has a maximum memory limit of 100 megabytes, and it is currently using 50 megabytes of memory. If the peak memory usage was 90 megabytes, then the fragmentation ratio would be 50/100 equals 0.5. However, if the peak memory usage was 150 megabytes, then the fragmentation ratio would be 50/150 equals 0.33. In this case, the fragmentation ratio is lower, even though the memory usage is less efficient. Therefore, the fragmentation ratio is not a reliable measure of memory usage in Redis if the peak memory usage is much larger than the current usage. In these cases, it is better to use other metrics, such as the memory footprint or the hit/miss ratio, to determine the efficiency of your Redis deployment. Redis provides two different methods for storing data on disk: Redis database, RDB, and append-only file, AOF. These two methods have different characteristics and trade-offs, and are suitable for different use cases. RDB is a point-in-time snapshot of the in-memory data in Redis. It is designed to be a compact and efficient representation of the data, and is suitable for frequent backups. To create an RDB file, Redis forks a child process, which saves the data to disk while the main process continues to serve clients. This allows Redis to create RDB files quickly, with minimal impact on performance. AOF, on the other hand, is a log of all the write operations performed by Redis. It is designed to be a durable representation of the data, and is suitable for recovering from failures. To create an AOF file, Redis logs each write operation to the AOF file as it is performed. This allows Redis to recover from failures by replaying the write operations in the AOF file. There are several key differences between RDB and AOF. RDB is faster and more efficient, but is less durable than AOF. RDB is also less flexible, as it can only be used to create point-in-time snapshots of the data. In contrast, AOF is slower and less efficient, but is more durable and flexible. AOF can be used to recover from failures, and can be configured to record more or less information about the write operations performed by Redis. In general, RDB is suitable for frequent backups, where the data can be reconstructed from the latest RDB file. AOF is suitable for recovering from failures, where the data needs to be preserved as closely as possible to its original state. Depending on your specific requirements, you may choose to use RDB, AOF, or both. The decouplings of publishers and subscribers can allow for greater scalability and a more dynamic network topology. Yes, that's correct. In the publish/subscribe, pub/sub pattern, publishers and subscribers are decoupled, which means that they do not need to know about each other in order to communicate. This allows for greater scalability and a more dynamic network topology. In a pub/sub system, publishers and subscribers are connected to a message broker, which acts as an intermediary between them. Publishers send messages to the broker, which then forwards the messages to the appropriate subscribers. Because publishers and subscribers do not need to know about each other, they can be added or removed from the system without affecting the other components. This decoupling of publishers and subscribers allows for greater scalability, because it allows the system to handle more publishers and subscribers without affecting the performance of the overall system. It also allows for a more dynamic network topology, because publishers and subscribers can be added or removed from the system without disrupting the communication between them. Overall, the decoupling of publishers and subscribers in the pub/sub pattern allows for a more flexible and scalable system, which can be useful for building real-time applications that need to handle large volumes of data. Redis provides a distributed locking mechanism, which can be used to implement locks across multiple processes or servers. This can be useful for coordinating access to shared resources, and for implementing critical sections and other synchronization mechanisms. In Redis, a lock is implemented using a set command with an x seconds and px milliseconds argument. This sets the value of a key, and also specifies that the key should be automatically deleted after the specified amount of time. For example, the following command creates a lock with a 10-second timeout. Set lock key mylock x10. To acquire a lock, a client first checks if the lock is available by using the get command. If the key does not exist or has expired, the client can acquire the lock by setting the key as described above. If the key already exists, then the lock is already held by another client, and the client must wait and try again later. To release a lock, a client simply deletes the key using the del command. For example, del lock key. In this way, Redis locks can
Just suck. I'm just gonna finish this and then I'm gonna stop here.
In this way, Redis locks can be used to coordinate access to shared resources across multiple processes or servers. However, it is important to be careful when using Redis locks, as they are not always reliable. In particular, Redis locks can be lost if the client holding the lock crashes or is disconnected from Redis, or if the timeout expires before the client releases the lock. For this reason, it is important to use Redis locks carefully, and to consider other synchronization mechanisms if necessary. Partitioning is a common technique for scaling distributed systems, and is often used in distributed databases like Redis. In partitioning, the data in a distributed system is divided into smaller, independent units, known as partitions. Each partition can be stored on a separate node in the system, allowing the system to scale horizontally by adding more nodes. There are several different ways to partition data in a distributed system. One common approach is to use a consistent hashing algorithm, which assigns each piece of data to a particular partition based on a hash of its key. This allows the system to evenly distribute the data across the partitions, and to dynamically add or remove partitions without needing to move large amounts of data. However, partitioning also has some potential drawbacks. One of the main challenges with partitioning is dealing with uneven data distribution, where some partitions are much larger or more active than others. This can lead to hotspots, where a small number of partitions are heavily overloaded, while the rest of the system is idle. Another challenge with partitioning is maintaining consistency across the partitions. In a distributed system, it is possible for partitions to become out of sync with each other, which can lead to inconsistencies in the data. To address this, many distributed systems use consistency protocols, such as quorums or leader-based replication, to ensure that data is consistent across the partitions. Overall, partitioning is a useful technique for scaling distributed systems, but it also introduces some challenges that need to be carefully managed. Redis provides two different mechanisms for achieving high availability, HA, for a Redis data store, Redis Sentinel and Redis cluster. Redis Sentinel is a distributed system that provides HA for Redis. It does this by automatically detecting when a Redis server has failed, and then promoting one of the slave servers to be the new master. This allows Redis to continue operating even if the master server fails, with minimal downtime. Redis cluster is a distributed system that allows you to shard your data across multiple Redis nodes. This allows you to horizontally scale your Redis deployment, and provides automatic data partitioning and rebalancing, which can improve performance and availability. Both Redis Sentinel and Redis cluster can be used to provide HA for a Redis data store. Sentinel is simpler to set up and use, but is less scalable and flexible than cluster. Sentinel is suitable for small to medium-sized deployments, where the data can fit on a single Redis server. Cluster is more complex to set up and use, but is more scalable and flexible, and is suitable for larger deployments, where the data is too large to fit on a single Redis server. Which one you choose depends on your specific requirements. If you need a simple, easy-to-use solution for providing HA for your Redis data store, then Sentinel may be a good choice. If you need a more scalable and flexible solution, then Cluster may be a better choice. To partition a Redis database, you can use Redis Cluster, which is a distributed system that allows you to shard your data across multiple Redis nodes. Redis Cluster provides automatic data partitioning and rebalancing, which can improve the performance and availability of your Redis deployment. To use Redis Cluster, you first need to set up a cluster of Redis nodes. This typically involves deploying multiple Redis servers on different machines, and configuring them to communicate with each other. Once the cluster is set up, you can start partitioning your data. To partition your data, you can use the cluster command in Redis, which provides a range of subcommands for managing the cluster. For example, the cluster add slot command can be used to add a new slot to the cluster, which will be used to store a range of keys. The cluster set slot command can then be used to assign a particular key or range of keys to a particular slot. For example, to partition the keys in your database into 10,000 slots, you could run the following commands. For I in 09999, do cluster add slot $I done. This will create 10,000 new slots in the cluster, which can be used to store keys. You can then use the cluster set slot command to assign keys to the appropriate slot. For example, cluster set slot 0 key, user asterisk. This will assign all keys that match the pattern, user asterisk, to slot 0 in the cluster. You can repeat this process for other key patterns, to distribute your keys evenly across the slots in the cluster. Once your keys have been partitioned into slots, Redis cluster will automatically distribute the slots across the nodes in the cluster, and will rebalance the data as needed. This allows you to scale your Redis deployment horizontally, by adding more nodes to the cluster, without needing to manually move or redistribute the data. I hope this helps. Let me know if you have any other questions about partitioning a Redis database. Yes, that's correct. Redis provides several different mechanisms that can be used to scale a Redis deployment to multiple nodes, including pipelines, ping-pong, and publish/subscribe, pub/sub. Pipelines in Redis allow multiple commands to be sent to the server in a single request, and then executed in batch. This can improve the performance of Redis, by reducing the overhead of sending and receiving multiple requests and responses. Ping-pong is a simple protocol that allows a client to measure the round-trip time, RTT, to the server. By measuring the RTT, the client can determine which server in a cluster is the fastest, and can then direct requests to that server. This can improve the performance of Redis by reducing the latency of client-server communication. Pub/sub in Redis allows clients to subscribe to channels and receive messages that are published to those channels. This can be used to build real-time applications, where clients receive updates from Redis in real time, without the need to constantly poll the server for new data. All of these mechanisms can be used to improve the performance and scalability of a Redis deployment that spans multiple nodes. By using pipelines, ping-pong, and pub/sub, you can reduce the overhead of communication between the nodes, and improve the performance and scalability of your Redis deployment. In Redis, you can use the expire command to set an expiration time for a key. This allows you to specify that the key should be automatically deleted after a certain amount of time. For example, if you have a key called access token that represents an access token, you could set an expiration time for the key using the following command. Expire access token 3600. This will set the expiration time for the access token key to 3600 seconds, or 1 hour. After this amount of time, the key will be automatically deleted by Redis. You can also use the TTL command to query the expiration time for a key. This command returns the remaining time in seconds before the key expires, or -1 if the key does not have an expiration time. For example, TTL access token. This will return the remaining time in seconds before the access token key expires, or -1 if the key does not have an expiration time. In your case, where the access token key represents an access token, setting an expiration time for the key can be useful for implementing token expiration. By setting an expiration time for the key, you can ensure that the access token is automatically invalidated after a certain amount of time, which can help to improve security. I hope this helps. Let me know if you have any other questions about using the expire and
Yeah, I'm gonna stop here, I have stuff to do. But I'll try my best to come back tomorrow or Saturday. Probably tomorrow. And I think I'm gonna try to be more consistent, but then spend less time, because I think one of the things that is making me be less consistent is that I have a lot of stuff to do off stream. A lot of stuff that I'm doing off stream, and then usually when I stream, I want to stay for a long time. So that stops me from being more consistent. So I think I'm gonna change that and try to be more consistent and just spend less time streaming each time, so that way is something that I can get done. I know that I will devote certain amount of time, and then I can get done, and I can do the other stuff that I have to do outside of streaming. So yeah, I'll try my best to come back tomorrow, and we will only not come back if I have something else shows up, but I'll probably come back tomorrow for 1 hour and a half to continue to study this